Good evening, everyone out there in Zoom land. Happy to be here tonight. My name is Aleph Johnston-Bloom. I am one of the forecasters for the Chugach National Forest Avalanche Information Center, and I'm excited to spend the evening or the next, hour and a half so with you tonight. I'm gonna be talking about persistent and deep persistent slab avalanches this evening. And I'm really excited that in a little bit, I will be joined by Allie and Jed from HPAC Avalanche Center. We'll get to hear from them in a little while. And as I said before, I want to thank you for joining. This whole session will be recorded as well as the chat, so just keep that in mind. Feel free to use the chat box for discussion, but if you have questions, please put them in the Q&A box. We are including time at the end for questions and discussion. So we're not going to interrupt the presentation for questions, but we're excited to have a conversation with you all at the end of the presentation. And before I do head out into persistent slabs and deep persistent slabs, I'd like to invite Wade Phillips from the board, the CNFAIC, Friends of the CNFAIC board, to chat a little bit.
Thanks, Aleph. And thanks everybody for coming out tonight. We're really excited to be here, and thank you for being a part of our local backcountry community and coming out for some avalanche awareness. We depend on your donations and the donations of our sponsors to support the forecasters, to help make sure they're kitted up and geared up, to help pay for salaries and our series of weather stations throughout the Chugach National Forest, the Front Range, and over to Hatcher Pass. So if you can make a donation tonight, we'd really appreciate it. If you're not a member, we're kicking off a little thank you this year. Anybody who's a member this year, we're going to be giving away 3 pairs of skis thanks to our really generous sponsors at Ski AK. So on the 15th of January, anybody who's a member, whether you're already signed up or if you signed up between now and then, we've got a pair of Faction Dictators, a pair of Black Diamond Helio 95s, and a pair of Rossignol Seek 7 Tours. And we're going to be giving each pair away to a random CNFAIC member. So get on over to our website, join, make a donation. We really appreciate your support, and thanks for coming out. Thanks, Aleph.
Thanks, Wade. Usually these events, these forecaster chats, are hosted by local businesses, and traditionally in Girdwood, 2 local businesses, both Alyeska Resort and Powder Hound, have sponsored these events in the past, and so we wanted to highlight them again tonight. I'd love to be sitting in the Powder Hound shop or in front of the Sitzmark or on the Sitzmark stage giving this presentation, but hopefully next season. But we definitely want to give a shout out to Powder Hound, and this is a little message from them. We support avalanche safety and encourage our team to practice the know before you go mentality. As retail professionals who interact with individuals that are going out into the backcountry, we feel it's our responsibility to educate our customers on the possible dangers they may encounter. We ensure that they are purchasing the most up-to-date gear and direct them to the proper resources to build their knowledge. And they also wanted to highlight a special that they're running during the month of December for getting a complimentary bottle of wine with a purchase of $1,000 or more. And they have a club. If you've collected 3 Powder Hound bottles of wine from different years, you can bring them in and get a free pair of skis. Also want to thank Alyeska as well. They've been a big sponsor of ours over the years and have donated a lot. Last year, they sponsored an entire weather station. And I think a lot of folks are pretty excited that they are opening up this week. On the 17th, there'll be pass holder day. And then on the 18th, it's open for everyone. And their motto this year is ski well and be well. So thanks to both those businesses. And in general, thanks for all of our local sponsors. And we just appreciate that you're still supporting us during this crazy year. So tonight, I'm gonna talk about persistent and deep persistent slabs. I'm gonna give a brief intro into how persistent weak layers are formed. I'll talk about it a little bit later. I'm not doing the full kind of all the science behind everything, but I'm kind of touching on these because I think it's important. I'm going to talk about a few notable avalanches and cycles in the Turnagain Pass forecast area. And then I'm really excited to have my friends and colleagues, Allie and Jed from Hatcher Pass Avalanche Center come on and talk about a notable avalanche season and cycle at Hatcher Pass and a few of the differences in dealing with forecasting there. And then we're going to just chat a bit about what it's like to be avalanche forecasters dealing with persistent and deep persistent slab issues, and then hopefully answer some of your questions. So one of the things tonight too, I think, just thinking about this as I'm talking out into Zoom land, we're having a conversation. Unfortunately, I'd love to just sit down and chat about this, but I'm going to talk to my computer. So here we go. Persistent slabs and deep persistent slabs are two of the avalanche problems that we use in our forecasts. And I'm not going to go into all the avalanche problems tonight, but I'm highlighting these two because they're particularly tricky and people get caught in avalanches, persistent slab avalanches and deep persistent slab avalanches, all types of people. It catches and kills people who are novices to experts. And I think a big part of this is that, we're thinking about all these avalanche problems and that not all avalanche problems are created equal, which is a big deal. So many of you probably have read this definition before, but I think it's pretty important. It's to go over it just at the start. So we're talking about persistent slab avalanches. So it's a release of a cohesive layer of soft to hard snow, a slab, when the bond to an underlying persistent weak layer breaks. Persistent layers include surface hoar, depth hoar, near surface facets, or faceted snow. Persistent weak layers can continue to produce avalanches for days, weeks, or even months, making them especially dangerous and tricky. As additional snow and wind events build a thicker slab on top of the persistent weak layer, this avalanche problem may develop into a deep persistent slab. And obviously, they stick around. That's why they're called persistent. And I think you'll notice if you read our forecast often, and this is a pretty industry standard, is that to keep track of these persistent weak layers, we name them after the date or the holiday they were buried with surface hoar and near surface facets. If some of you remember, we've had Thanksgiving buried surface hoar or the MLK facets, or the time frame they formed. So for basal facets and depth hoar, i.e. the October facets. So as I said at the beginning, not all avalanche problems are created equal. And this applies to avalanche accidents in Alaska. Last winter, I went back and looked through all the accident reports from 2009 so from the fall of 2009 to the spring of 2019. And I looked at 27 accidents resulting in 34 fatalities, and 17 of those accident reports noted having persistent weak layers as the layer that the avalanches failed on. And so I think that's significant. I also looked into some other papers from some other areas, and Colorado noted that 82% of all of their avalanche accidents are attributed to persistent weak layers. And we can get into that a little bit more as we go about why that would maybe be in different climates. But the other part is, so as we jump, that ended in the spring of 2019. So last fall, 2019-20, into that season, both the avalanche fatalities in South Central, so both the avalanche fatality in Boulder Creek, south of Cooper Landing, and the fatality at Hatcher Pass, the avalanches failed on persistent weak layers. And as we keep going into this, all persistent weak layers are also not created equal. And this is just a sampling. This was a study done by Jörg Schweitzer and Ian McCammon and Bruce Jameson, but talking about surface hoar layers in Canada and Switzerland, just in the small sample size but that surface hoar, facets, and depth hoar attribute a large percentage of total avalanches. And there's been many different studies done on this in different places that illustrate the same point, that the avalanches, most of the avalanches that kill people are with these persistent weak layers. So how do these pesky layers form, these dangerous layers? And I know you're out there, and I'm sure some of you maybe have never taken an avalanche class. I know there's probably maybe even other pros listening, people taken many classes, read many books. So I'm going to touch on some things with this, and we're just going to get into it real quick with, each winter we have a series of storms, and each storm has another unique layer over the terrain. Snow falls from the sky in all different forms, and I'm definitely not going to get into why different flakes fall from the sky this evening. That's for another night. And it forms all these different layers. I'm not going to go way into the science and the mechanics, but we are going to talk tonight a bit about water vapor movement and temperature. To start off, we're going to touch on the snowpack and whether things are faceting or rounding. I'm not going to talk too much about this one because we're talking about persistent weak layers, and rounding is not a persistent weak layer. So rounding is common when the snowpack is deep and the air temperatures are warm. So this is important to remember as we go along with thinking about how what different seasons are like, and how avalanche problems persist or don't persist. And down at the bottom there's just a quick little diagram of thinking about a snowflake that falls from the sky as it sits and changes. This is one of the types of changing. So rounding goes from that nice stellar to that kind of lumpy looking thing over on the right, the round. So here's that beautiful stellar. And when we're talking about vapor, when it's warm, vapor, when it's generally warm and deep, the vapor kind of sticks around and it moves around the actual snowflake and changes the way the snowflake looks. Over time, the arms round off as the vapor moves around just that little flake and fills in and makes it change into rounded grains that stick together. The other way the snowpack can go is faceting. And faceting is common when the snowpack is shallow and the air temperatures are cold. So here we have that on the left, that rounded grain, and it's changing over time to the grain on the right. So I'm going to show a little bit more about that. So as we're thinking about the snowpack changing over time, as I said before, it has to do with the depth of the snow and temperatures. And air temperature, when the snowpack is shallow, can influence what happens to the snow on the ground. Water vapor likes to move from warm to cold and try to balance out. And if the air is really cold, the ground's always relatively warm, that vapor is going to move more rapidly. And the colder the air is, and the shallower it is, that will happen even faster. So when we have a snowstorm, we get maybe some snow in November, and it sits around and it's cold and clear through December, mid-December, we could have a very shallow snowpack and cold air temperatures, and we could get a lot of this faceting. So here's a little video thinking about that vapor moving through the snowpack. So the vapor is moving, and as it moves, it actually changes the way the grain looks. We're going to play that one more time. So it's moving from warm to cold and changing the grains. So again, shallower the snowpack, the colder the air temperatures, the more vapor movement and the more changing of the grains that are on the ground. And so this is grains that have just started to become faceted or edgy. Here, they're getting more as more vapor moves as they change, getting even more edgy. And here, it's becoming advanced facets. So you can see the edges, those layers that were growing in that video, those edges or striations in the grains. And if it really develops, it can become these cup-shaped crystals that are really edgy, called depth hoar. You can see the angles. And many people refer to this as sugar snow. One of the things with facets is that they can also grow around vegetation because there's more air for vapor to move around. So ground is cold, there's air around the vegetation. It's easier for the air temperature. So ground is warm, air is cold, there's more room for that vapor to move around in that vegetation, and you can get more faceting around the vegetation. In addition, you can also get a lot of faceting around rocks, which is sometimes referred to as cavity hoar. And so as we look at some of these avalanche accidents in places where facets grow, it's important to think about facets growing around rocks. This picture was in my poster, and I'm going to talk more about this avalanche a little bit later on in the presentation. But looking at all this rocky terrain, this is an avalanche on Pastoral. There's a lot of thinking about all that rocky terrain and potentially facets, if there was some snow on there in the early season, facets growing over those rocks. Because rocks hold heat, get buried, more vapor moves around the rocks, more faceting. So as I said before, it's referred to as sugar snow. You'll hear that a lot when people are talking about that. And it looks, as you toss, you can pick up sugar snow and toss it in your hand. It looks like, what you'd put in a cookie. If it gets big enough though, it might be kind of crunchy, too crunchy. And you can see again that those angular grains there. So that was the quick on faceting. Again, we're thinking about vapor. So where vapor can move in situations when the air temperature is colder, ground is warmer, and it's shallow, and that vapor moves and changes that snow to those weaker snow grains. That's faceting, and when it's developed is depth hoar.
Happy St. Patrick's Day from the Chugach National Forest Avalanche Center. Spring is here and with it an avalanche cycle. Every day since Monday we've had reports of large human-triggered avalanches and naturals across the region, including Girdwood, Placer Valley, Turnagain Pass, Lost Lake, Summit Lake, and Grandview. A very large natural avalanche released on Tuesday on a northeast aspect of Skookum Valley with a crown a mile wide. Most of this activity has occurred below 3,000 feet, and slabs have been in the 2 to 4 foot thick range and large enough to bury and kill a person. Some of these avalanches have been remotely triggered, while others have released after a skier or rider were well onto the slope. So far, we haven't received any reports of anyone fully buried or injured, luckily, but several people have taken rides and deployed airbags this week. Most of this activity has been failing on weak faceted snow from January. A big storm last weekend overloaded these older weak layers, and sun and above freezing temperatures have us concerned this weekend. We at the Chugach National Forest want everyone home safely. This means if sunny weather inspires you into the mountains this weekend, choose mellow, low-angled terrain, less than 30 degrees, and avoid run-out zones. Triggering a large slab avalanche could be unsurvivable with our current snowpack and warm temperatures. A big shout out, too, to all the snow machiners, skiers, and boarders who've sent us photos and observations this week.
So with that video from Heather, one of the big things with all of this is that those facets or depth hoar need to be buried by a slab. And so we'll talk about that more as I go on this evening. But yeah, you need the slab and you need the weak layer. And there was a number of great examples in there of those slab avalanches across much of the terrain in our forecast area. So the next persistent weak layer I want to talk about is surface hoar. And I'm sure people recognize this. Beautiful, sparkly on the surface. It looks like feathers. It's really important to remember with this, just and not get confused with facets, is that surface hoar doesn't fall from the sky or form within the snowpack. Surface hoar forms when it's cold and clear, and you can have, it's either calm or a very light wind. And it forms when relatively warm, moist air comes in contact with a cold snow surface. The vapor from the warm air will condense onto the surface of the snow, which is the equivalent of winter dew. So it has to do the air. So there's vapor depositing onto the snow surface. So the moisture is in the air and the snow is cold. This isn't the faceting that I just talked about. And I think people can get fairly confused about this. So again, this doesn't fall from the sky and doesn't form within the snowpack. It forms on the surface. You can also, and you can tell this as well because it will also be on things like trees or your car, that it's not coming out of the snow, it's being deposited or it's growing onto the snow. And here's a little video. It's pretty subtle of surface hoar actually growing. Here's a picture of surface hoar standing upright from the surface. Surface hoar, when it's on the surface, isn't an issue. Similarly to facets, if the whole snowpack is faceted, it's not an issue. It becomes an issue when there's a slab on top. And so when you see surface hoar, it's really important to note where it is. Where it grows can vary with elevation due to how much moisture is in the air. It can be even in different drainages. Here we have a lot of, in the Turnagain Pass, Girdwood forecast area, the proximity to the ocean, to moisture sources, it can grow differently in different drainages. It can depend where the wind blew. So maybe it does grow and the wind blows and knocks it over, or you have just that slight, a little bit more wind as it's forming that can move the vapor around and have it grow. And it often is also determined with where those fog layers hang. People will talk about it as a bathtub ring of surface hoar that it ties in. Inversions can have an effect on where cold air is trapped and moisture is. And it can be particularly tricky. Once it's buried, sometimes it's really hard to find in pits. Surface hoar is also something where avalanches fail on lower slope angles. And because it's so tricky with, could be on part of a mountain and not the other part, or a certain elevation, it's killed many avalanche professionals. You could start a run, start a ski run or on your snow machine, and in one elevation band have no avalanche issues, but then change something a little bit to where a pocket of surface hoar is buried and cause an avalanche. So we spend a lot of time trying to track and figure out where these layers of surface hoar are going to be. It's also more of an issue when it's on harder surfaces. So when you have surface hoar on top of a hard wind crust or a melt freeze crust, it can be even more dangerous, more of a weak layer. And so one of the things that we're doing in trying to figure out when these surface hoar layers are going to form is tracking the weather. And here is one of the periods from 2016 where we had a surface hoar grow. And you can see there's still some humidity, but it's colder and calm, really pretty light winds. And we had surface hoar grow. And there's an example of that surface hoar that grew during that time. But then we had 15 inches of snow fall on top of it. And there you can see that buried surface hoar layer really well in that snow pit wall. Sometimes as it gets buried more deeply, it's harder to see it. Sometimes surface hoar is a bit smaller and harder to see, but can still be a dangerous weak layer. And so after that snow fell in our advisory area, the avalanche danger rose. And that particular layer was the cause of 10 days of human-triggered avalanches in Turnagain Pass and Summit Lake. It was a persistent slab issue. Not to jump around, so from 2016, we're going to jump back to 2008, but this is a really notable weak layer of where we had buried surface hoar, the notable avalanche. You can go onto our website and read the accident report on our accident page. This was an avalanche that buried a skier who did survive, but you can see here, this is Sunburst, and this is a very large avalanche that failed on buried surface hoar. And the little arrow there is noting a party of skiers in the path of the slide. This is a pretty iconic photo from that avalanche. There's the skier there, and you can actually see the slab breaking out with tracks on top. So this is another big key part of why persistent slab avalanches can be so dangerous, is that you can have multiple tracks on a slope. You may not see any signs of instability, but they can still, this buried weak layer can be lurking below feet of snow. And here is a picture of the deepest part of the crown from that Sunburst avalanche. So I've covered faceting at the bottom of the snowpack, surface hoar on the top of the snowpack, and now we're going to go into faceting at the surface. So surface faceting, and is usually referred to as near surface faceting, and a little bit with faceting and crusts together. So near surface facets, again, we're talking about vapor moving around. Near surface facets are driven by vapor moving around right at the surface of the snow. And so this is when the air temperature is different than the surface of the snow temperature. And depending on which is warmer, the vapor will move that way. If the snow is warmer, vapor will move out of the snow. If the air is warmer, vapor will move into the snow. And as that fluctuation happens, you can get faceting at the surface. And you can see here, again, it's starting to look edgy and sugary. And so cold, this also happens when it's cold and clear and there's no precipitation. And you can have some wind happening with this. You can have more wind, but as it's sitting there, that vapor just moves around back and forth right at the surface, because that vapor can be, all day kind of moving there, and over a period of time get quite faceted or quite edgy. People often refer to it as loud powder or recycled powder. Sometimes you'll have a storm where it was kind of warmer and wetter, and then it gets cold and clear and sits around, and the skiing and riding actually gets better because the surface snow gets looser. So here you can see near surface facets. And near surface faceting, the longer the snowpack sits there, the deeper it can actually go into the facets. It can facet deeper into the snowpack. Here's another picture of the facets. And so again, as we're getting into this vapor and vapor moving, we're going to throw another element into vapor moving, and we're going to add crusts. This is a sunburst the other day, and there's some rain runnels and a little bit of snow on it. And so crusts, especially right as they're forming when they're warm and wet, when they're water, just as they're cooling, there often a lot of vapor moves around them. So below and above, if you get cold snow on a wet crust, that can facet out really quickly. The crust can also trap vapor, and so you can get faceting below the crust as well as above the crust. And the other part with crusts is they make really good bed surfaces. So if you have facets, you have a crust, you have facets form on top because of the vapor movement, and then you get a slab on top. You have pretty much all your ingredients for an avalanche right there. So you'll also see us tracking crusts in snowpacks and looking for faceting around those crusts. So here you have a sun crust with surface facets just on top of it. So with all of this, so facets on the ground, so near surface facets and surface hoar, they're all issues if they're buried by a slab. In this photo here, there's facets and more facets, and down at the bottom, even more facets. And so if all you have is facets, most of the time there's no issue because you don't have a slab. You just have this coat, you could have, even here, you could have feet of sugary, mostly sugary snow, and not an issue. I think Jed and Allie are going to talk a little bit more about this in regards to Hatcher Pass. But with all of these things, surface hoar, when surface hoar gets buried in the snowpack, one big thing to remember with it is that it doesn't become facets, it's buried surface hoar. Surface hoar, when it's buried, sometimes people want to call it depth hoar, but it's still just buried surface hoar. And this brings us into thinking about slabs and how deeply is that persistent weak layer buried. So it could be just in the upper couple feet of the snowpack. And when it's like that, we refer to it as a persistent slab. Oftentimes with these persistent slabs, you will still get, at least initially, get signs of instability. You'll have cracking, you'll feel big collapses, and even people may be triggering avalanches. But as more time goes on, a lot of times these signs of instability decrease, but the issue is still there. The persistent weak layer is still there. There's still a slab, and people may trigger avalanches days or even weeks after the storm and after the layer was buried. If we get even more snow on top of that layer and we get, more than 3 feet deep, we start to call these slabs deep slabs. The other part with deep slabs is their depth. They're often hard, or they're usually hard snow, and it gets even harder to determine whether or not they're reactive, because those signs of instability pretty much go away completely. But that weak layer is buried deeply below all that snow. The other part that makes this so tricky is that thinking about whether or not you, as a skier or a snow machiner, if your weight could actually trigger an avalanche down on that weak layer of snow. As the slab gets deeper and deeper, it's harder to impact that weak layer. But the problem is that we don't have X-ray vision, and we can't see how the snowpack is brushed across the terrain. And you could have an area where it's very thin, and you could easily trigger the avalanche with your snow machine or on your skis. But just a few feet over, it's incredibly deep. And that's why having a persistent weak layer that's buried so deeply, it's one of the biggest challenges with it. And so this is actually something that Wendy, the director of the Avalanche Center, worked on. And it really talks about why deep slabs, why they're so tricky. And I think they created these little meters down at the bottom, but the avalanche behavior is much more unpredictable. The other part with this is that remote triggers are likely. And so that is that you wouldn't actually have to necessarily be on the slope that avalanches, you could be adjacent to it or below it. And so, if you step in the shallow spot to the side of the avalanche path, or you drive over the shallow path, shallow point to the side of the path, or cut under, you could trigger that very deep slab if you find that spot. And the other thing is that tests and observations are unreliable. What I was just talking about, you're not getting those signs of instability. So I'm gonna, take us back just a couple of years. I've been using a photo in this to kind of advertise this presentation from that pastoral avalanche. And this dragon image is actually something I put in the forecast earlier, which is kind of silly, but earlier, about a week before the pastoral avalanche released. So deep slab avalanches are like messing with a sleeping dragon. You might tiptoe around it, but waking the dragon up will be terrible, and avoidance is key. And so if you look at the snowpack over on the right, you have a dense slab, you have facets, you have a melt freeze crust, and you have more facets. So you have the ingredients there for a slab avalanche. You can see a picture of that sugary snow over there. And then what happens next is that we get more snow on top of that. December 8th snow. So I'm writing this on December 15th. We added 4 to 6 inches of water weight, multiple feet of snow on top of that structure from the 8th. And so on December 20th, 2 skiers triggered this avalanche. And the red notes where the party was when the avalanche occurred. And you can see the extent of the slide. In addition, it caused another avalanche quite a ways away from where they triggered the avalanche. So delving in a little bit more, Heather went the next day and investigated this avalanche, and she found their approximate trigger point from where they had been skinning up along the black route there. And then that white route is where they exited. They actually were able to hide behind kind of that little bump and avoid being caught in the avalanche. But they heard the avalanche, they heard a really loud, what they thought was an explosion, saw the snow coming down, and were able to move, kind of tuck behind and get out of the way. One of them lost a ski and had to run there. So that next day, when Heather was investigating the avalanche, she looked up and got a photo of the crown. And she estimated that the crown there in the deepest part was 10 to 12 feet deep. And so she also dug a snow pit near the trigger point, and she found facets at the bottom of the snowpack, as well as crusts underneath the slab. So that those folks, as they were traveling, found that thinner spot that was enough to trigger the avalanche that traveled all the way up the slope, across the slope, and then was even, that weak layer was enough that it could fail and sympathetically and cause the other avalanche on that other ridge. And so I think that part is really important, thinking about being able to step one place and cause the avalanche in a different spot, especially when there's facets and crusts. To have all these slab avalanches happen, you need to have the slab and the weak layer, and to have a big avalanche, those layers have to be continuous and be brushed across the terrain. If you have something that breaks it up, say a wind event, or something so that maybe the slab isn't as continuous or the weak layer isn't as continuous, maybe the avalanche will be more confined. But when you throw in a crust that goes across a huge area, a weak layer that goes across a huge area, and a slab across a huge area, that makes the setup for something like this just is, it's, you know, all those ingredients are there, and it's quite scary. So in thinking about these 3 layers, and, you know, our persistent weak layers in the snowpack, how would you know if there wasn't an avalanche forecast? And so I think a big part of that is watching the weather and then thinking about those processes. You know, did the season start out cold and clear with just a few storms? And did that snow sit around? And was it cold? Do you think that snowpack faceted out? Or did the snow, you know, did we have a season that starts with one big heavy wet storm, and then just we get storm upon storm upon storm? All these pieces, you know, are part of what forecasters do. And then if you are, you know, headed to a range or an area where there's no avalanche forecast, those are things you're going to want to pay attention to and understand. You know, even just looking here, you know, maybe I'm keying into the idea that we could have that patchy freezing fog. Maybe there's a good time for surface hoar to be growing. I think the big thing with all of this and thinking about persistent slabs and deep persistent slabs and whether or not you can, ski slopes or ride slopes, whether or not these problems exist, is that each season is different. And you have to, because of temperature trends and precipitation types and amounts, as well as breaks between storms and wind events, they all determine what the layers on the ground, each layer is like. And some seasons are more stable and better for big objectives. And some seasons, and sometimes these layers are problems for the most or all of the season. Sometimes it's some of both. You'll have part of the season. One of the things I was even remarking, I was chatting with another forecaster the other day, is when we get in these cycles when it's really snowy, it's great, but it's hard, it's harder to get into the Alpine to get a look around and see what's happening. But then as soon as we get cold, clear weather, another weak layer is forming. And so those patterns. And one of the things I like to do is go back and look at the past and look at how storms and weak layers evolve over a winter. And so the Turnagain Pass area has these forecast archives, and you can go back and look at how each season, what avalanche problems were designated. And just in these last 5 ones that are up here, the most recent, the last 4, that we've definitely had a lot of persistent issues because we've had some winters have been colder, some have had these big swings. But if we go back to 15, 16, we had almost no persistent issues because it was a really warm and wet winter. And so we had a lot of rounding versus those persistent issues. That was also the major glide year, but that's a whole other can of worms that I'm not going to get into tonight. The other thing to think about this is with these seasons, again, because I talked about temperatures and vapor, and this all kind of ties into what climate the snowpack is being influenced by. And there's different snow climates, and Wendy actually did a paper about what climate Turnagain Pass often is and how it changes. And then Heather added onto that in another research paper with Nikki Champion, who's now a forecaster in Utah. So I would recommend going and looking at both of those and thinking about these climates. I now would like to invite my colleagues to join. We have Jed and Allie from Hatcher Pass Avalanche Center. They're the forecasters and founders, and they're going to talk some more about avalanches and persistent issues in their area.
Thanks, Aleph. Yeah, my name is Jed Workman, and I'm a forecaster at Hatcher Pass Avalanche Center along with Allie Barker, who I'll introduce here in just a minute as we share our presentation. And thanks for including us in this conversation. It's really awesome and a great way to reach out to a lot of people and share information. The Hatcher Pass Avalanche Center, just a quick little introduction. We've been around for about 12 years. In the last 2 years, we became our own standalone nonprofit, which was a big move. And we're funded entirely by your donations, our community. And then we do fundraising, other types of fundraising, and we do apply for certain grants. So it's really our community that keeps us alive. And we don't receive any funds from the state or the feds. And so it just makes it that much more important that you keep your community avalanche center alive. And your donations have gone a long way. And I see a lot of people who are on here tonight that have donated. So thank you very much. We also want to thank the Matsu Health Foundation, who recently granted us a large sum of money to assist us in forecasting and some educational programs, which this would fall under too. And with that, I'm going to share my screen. Is that working?
Looks great, Jen.
Oh, thanks, Aleph, for verifying that. So here you can see our page. So www.hpavalanche.org. If you're not familiar with that, please bookmark it. And then you can see the big circle around the donate button. That's our favorite button. Please hit that as often as you can. And then you see that we have the forecast button there, where you can go straight to the forecast, which you're seeing right now, with the beginning of it with the bottom line. And I just wanted to point people to those 3 tabs down there, the avalanche forecast, the weather tab, and the observations tab, which are a little bit hidden, but definitely worthwhile visiting. So to get back to the persistent slab topic of tonight, we're highlighting last season. And that was a unique season because we started out with a very warm and wet start. And in this picture, you can see a series of glide cracks, which if you ski down in Turnagain, you're probably very familiar with, but if you ski in Hatcher Pass, you may have never seen before. And so we had a very significantly different climactic or climate condition, which looks like a maritime snowpack, something you would see in Turnagain, which we rarely, if ever, see. And so the entire snowpack was very homogeneous, a bunch of rounds, as Aleph was talking about, with very little flaws in the snowpack. So no facets and no real layers to speak of, and it made for great skiing. And it was really safe. But as we'll get into here, as January rolled around, we got into an extreme drought of cold and dry weather, and that faceted out the surface of the snowpack, which was not a problem and made January skiing quite remarkable. But when that layer got loaded subsequently through the season, we entered into some avalanche cycles, and that was a problem. Something else we want to bring up here is if you look in this top corner, you can see that the number of avalanche forecasts where we issue persistent slab as a factor is really high. 17 of 32 forecasts in 2018 and 19, 16 of 27 in 2019 and 20, and you can see we're off to a pretty good start. We'll see where that percentage ends up at the end of the season. But we are quite often dealing with persistent slabs. This is the first of the year on 2020, so just after that nice warm wet start. And you can see we're already dealing with 5.5 feet of snow. And again, really good stability at that time. Not sure, what is this? I'm sorry, something went awry here. What is that? Let me just go back, apologies here. Oh, that's really strange. Maybe I can just go through our standard. Is that showing up?
No.
Okay. Wow. How about that?
Yep.
Okay, I'm going to stick into this format since I'm not really sure what happened with the other format. Anyway, so January, here's a picture of us skiing in January, and it was so cold and clear that the surface of the snowpack again was faceting out, and actually the skiing was improving, and any slab that was there was disappearing deeper and deeper into the snowpack. So again, we're going to review some of that January cycle. So here we're looking at the Independence Mine snow tell, and you can see that the air temperature minimum was in the negatives. It was in the single digits and the teens for almost the entire month of January, with a high of 28 degrees Fahrenheit. So pretty darn cold January. And if you come over here and you look at the snow water equivalent, you can see that we received very little water through that month, and that comes out to 0.7 inches of SWE, which translates to 7, maybe 10 inches of snow for the entire month. So not a big load, but definitely the conditions that Aleph's talking about for near surface faceting to occur. And in this pit, from the end of January, you can see the old snow from the warm, wet start at the base, and then you can see above that is all fist hard, 4-finger plus, just soft, faceted snow. This snowpack is pretty darn safe. We don't have the upside down snowpack problem here. This is right side up. But as we move forward, we'll see that we get a big load, and that's due to winds. So end of the month, right here on the 28th and the 29th, we see some really strong winds, and that's going to push a lot of snow and deposit it into a slab on top of that weak snow, and it's going to overload it, and it's most likely going to fail. So immediately after that wind load, here are some of the avalanches that occurred, and they're very significant. This one on the Archangel Road, you can see crossed it. That's a D3 avalanche. That's very large. And over here on Marmot, you can see the crown is very wide. It continues to propagate across the slope. That's part of that continuity of that weak layer that Aleph was talking about that enables the propagation to travel long distances, which usually results in larger avalanches. And in this case, this one hit the road. So now that you have the setup for the season, I'm going to introduce Allie, and she's going to finish off that presentation.
Okay, so Jed has set the stage here for persistent weak layers, and now that you understand how they form and behave a little bit, thanks to Aleph, we'll continue talking about Hatcher. All of these avalanches, all of these cycles that we are talking about, all these avalanches are failing on persistent weak layer. Mostly facet, some depth hoar. We rarely get buried surface hoar at Hatcher Pass. So we're going to continue to look 5 days after the storm. We are seeing remotely triggered avalanches. This is pretty common again. With this persistent weak layer, after a new load of either snow or wind transported snow, you'll see naturals, and then maybe for a couple of days, and then typically we see human triggered and remote triggered, maybe even seeing remote triggers 2 to 3 weeks out with persistent slabs, which is one of the challenging factors in determining where to ski, ride, snow machine in the backcountry. So at this time, we're just going kind of chronologically through our persistent slabs last year after our dry cold spell in January that formed these weak layers. You can see we had a spike in wind around 79 miles an hour. And that again transported snow. And as a result, we see another natural avalanche cycle during and after the storm. Large and very large avalanches are occurring and failing again on these persistent weak layers. So another week or so after that cycle, our test results are improving, stability is improving, but this is one of those low probability, high consequence situations that we often talk about at Hatcher Pass, because we know that those weak grains are buried at the bottom of the snowpack, and it's just a matter of trying to understand when we're going to see them become reactive again. You might get out, in this case, 6 days later, people are riding steep slopes without any avalanche activity. And you might think you're getting away with it. Maybe you made a good decision, maybe we didn't. And then we get another load, 12 to 18 inches, and again, we are seeing that weak layer fail. So weak persistent grains again with D2 avalanches. And one more load. And then we have our really unfortunate fatality on 16 Mile last year. And this was an example of an isolated location. Often we talk about persistent slabs at Hatcher Pass being in not aspect dependent. We often see them on all aspects, all elevations, and that might change throughout the season. This got a particularly large wind load earlier in the season, and then a bunch of new snow, and was actually triggered from the bottom of the slope as the person was switching over their split board to try to skin up and out of this location. And then another remote trigger. And this is believed to be snow machiner actually crossing under this path. And hits the road, closes the road enough to be able to have to clear it. And these are, I think, remote triggers I want to just spend a second on because we have so many remote triggers, remotely triggered avalanches at Hatcher Pass. And you might not even know that you trigger it, and there might be a party below you. And so it's really important to understand when that's a potential factor and the potential consequences. Let's check out this video around the same time at Hatcher Pass of a persistent slab and look up and right of the snow machine. Okay, am I still with you? Can you still hear me, Aleph?
Yep, sound good.
Great. So most of you probably remember seeing that video from last year. Just a reminder, these persistent slab avalanches can travel long distances. I don't know if you could notice how far away that snow machiner remotely triggered that avalanche. And that was not the sound of the muffler. That was the avalanche. So let's remember, what are the weak grains? Are there persistent grains that we need to be concerned about? Where are they in the snowpack? How are they? What's the continuity of that weak layer? What's the propagation potential? These are all questions that we're asking ourselves when we're out there. So again, we're continuing the same cycle. And now we're seeing 2 to 5 days after a storm, still remotely triggering these weak grains. So most of you probably remember the Delia Creek avalanche last year. This was pretty fascinating. I'm really lucky that no one got injured, buried, or killed in this one. You can see the party of 3 on the left side that had skied down 5 to 10 minutes before the avalanche, and then the other skier where they remotely triggered this large avalanche, more than 1,000 feet wide, on the up track. And then the main avalanche sympathetically triggers the one to Looker's left. So this is a great example of continuity of the weak layer, propagation potential that exists, and also a low probability, high consequence situation that is sometimes not that easy to be able to test for, or to, sometimes it's a bit of a gamble. And after this avalanche, you know, on the 22nd, we continue to see some strong winds. Another avalanche cycle failing again on the same layer. And I put this in here because this is April 14th, but again, we're seeing that persistent weak layer reactive. So now we've seen the same layer reactive from basically the end of January through middle of April. So they don't often like to go away. And typically at Hatcher Pass, we have a shallower snowpack. And if it all facets out, we have great skiing. If we get a big load of snow and a slab on top, not so good, and we're worried about it. And then let's just look at, I'm almost done here, but this is one other example I wanted to pull up from 2018-19. And the important thing to note here is this avalanche was remotely triggered by the third skier. And this is a sunny side of Hatch, and there was no precipitation or loading event for almost 3 weeks. So this is just your classic low probability high consequence situation. Hard to predict, but they still happen. And I think that's it. So I will stop here on our forecast page and hand it back over to Aleph.
Thanks, Allie. And Jed, I think it's, you know, I think it's really good. I know a lot of people who are on tonight are folks who ski and ride at both locations. And I think you really hit on some of the parts of like what often is different at Hatcher. We had just before we kind of dive in more, we did have a question in the Q&A box from Erin Boone, and she wanted to know why you don't often have surface hoar at Hatcher Pass, which I thought was a good one.
If we do get surface hoar at Hatcher Pass, it often just gets gets blown over by the wind before it gets buried. And there have been a few times that it's buried, but yeah, it's really rare.
Maybe another factor is that we're pretty far inland. We're not near bodies of water, so the source for moist air, it just tends to be a drier location.
Yeah, we're right by the arm, and then even pretty close to the Gulf. So yeah, definitely. Yeah, I think the other part, I think that last season is pretty fascinating in that same layer of facets just like got reloaded and reloaded and reloaded.
Yeah. Yeah, and even though last year was a bit of an anomaly with the glide cycle in the beginning, you know, from the end of January on was pretty typical for Hatcher Pass.
Yeah. And it was interesting for us in many ways, like it was really warm and wet here in the beginning as well. I think it was like, you know, it rained in December, but then we had basically a switch turned in January, and it got cold and really didn't snow that much. And we definitely had persistent weak layers for much of the rest of the season as well. And we just really did not, I think we ended the season at 50% of average, where you all were like 120% of average or something?
Yeah.
Yeah.
I think it's pretty amazing to see a season flip-flop so extremely. Just when we thought we were going to have a stable, beautiful, safe season, it just flipped to a really touchy, dangerous situation.
And people are already really psyched on recreating there because it had been so good. Yeah. I think that part just of like, you know, getting used to things or having kind of preconceived notions about what an area's snowpack is like, I think happens a lot. I know even just when I moved here, I think I I was like, oh, this, that's where they film all the ski movies, and it's always, maritime snowpack, and it's always stable. And I think as, we get here and learn just how different, even within my forecast area, how different it can be in Summit Lake, having more persistent weak layers to Turnagain, and then thinking about what the snowpack is like at Hatcher, and the amounts of precipitation and the temperatures and the different events.
Yeah, I think most of the people on this call probably are familiar with those differences, but
Yeah.
if you're new to the area, it's really important to key into the different climates, the one that Turnagain tends to be and the one that Hatcher Pass tends to be. And you wouldn't want to assume that they're the same, because there's such big differences. Get into trouble pretty easily that way.
Yep, definitely. I think one of the things we all chatted about a little bit before we started this evening was, how are, in your forecasting, times that you think, like, when do you ever put those persistent weak layers away or to bed and say, let her rip? Or what are your thoughts on that?
I would say that we definitely have those conversations a lot. I think we'll be thinking about it, and then we might have a couple remote triggers that, where we see it rear its ugly head again. But typically, if we don't see any activity in terms of human trigger, remote triggers for, a couple weeks, we'll probably be at low for 1 week. If we don't see anything for another week, then we'll pull it out. It takes a while, because, at that point when we're about to do that, we'll probably have another dump of snow or some wind, and then it's right back in there. And that's, I think, one of the really interesting things that we continue to see at Hatcher Pass is we might have 5 inches of snow, or 5 to 10 inches of snow, and that's enough to have a big cycle again, at least for a few days.
Yeah, and reactivate.
It seems like if you're going to be somebody who uses Hatcher Pass or a similar, climate snowpack for a long period of time, like you're planning on a long life of skiing in an environment like that, you have to have an incredible amount of patience, because the cards don't stack up very well most of the time, and you just need to watch it very carefully and then choose those windows. Like when you were talking about big objectives, you really want to time that right. You wouldn't want to try to do that at the wrong time.
Yeah. I think that idea of having patience and figuring out, like, what, some seasons are the seasons, or there's, windows for things. I think, yeah, definitely can be a challenge. And I was talking to a friend the other day who was, we were talking about these deeper persistent slabs, and the idea of someone saying they're, skiing or riding and it feels good, right? The idea of you get into something and it feeling good, and just like how misleading that can be, because you really, like when you're not seeing signs of instability, or, even with test results not showing things, but there's that developed weak layer that down there. I think it's really hard to, people want it to be stable. Like, I want it to be stable. It would be great if I could just be like, oh yeah, great, it's green all the time. Mm-hmm. Ski it if it's white, ride it if it's white. But how I think getting people keyed into that of understanding.
I think that we've all talked about this so much, but that travel protocol, like if you're going to enter into a high consequence, low probability situation, and that's the setup, you really need to stack all the other cards in your favor. And that long time rule of only breaking one rule at a time is really important. So if you're gonna roll the dice a little bit, you want to stack every other odd in your favor.
Yeah. I think go ahead.
I think the other interesting thing is, if you look at our snowpack right now at Hatcher Pass, we have a persistent slab problem, but it's not the high continuity, it's more isolated right now. We have, so it's not nearly the problem that, say, we were looking at last year. It could become that, but it's not right now. So that also is different. Do we have a specific problem? Is it isolated? Is it widespread? What are we looking at, and at what elevations, and that can play into decision making too.
Definitely. Yeah, we have basal facets in the alpine. And so you'll see we've been keeping deep persistent in, we haven't had an avalanche on those facets now it's almost 2 weeks. And it's a bit hard because they are definitely still there, and your probe drops away, and even getting test results actually in shallow spots, and people some of that terrain has been tested, some of it hasn't, but it has a little bit of a similar, like if you look at a pit profile, has a look that's somewhat similar to that pastoral avalanche that I showed tonight. And so still having that lingering around. And yeah, it's definitely something evolution. I think one of the things we have in our lower snowpack is that we had a lot of rain, and that basically we have a really stout crust that insulates from triggering, as well as, we actually have, you can see where water was like running through the snowpack. But we have a couple good, are you guys up for a couple questions? And in general, for folks out in the audience, we're gonna answer questions now. If you have more, I have 2 great ones. I'm gonna start first, because this ties into what we were talking about, from Galen Hecht. I sometimes hear people talk about facets or healing. Can you talk about whether these weak layers can heal, and if so, how? And so we started talking about this. Some of the pieces are, they will actually, as they're sitting over time, especially as you add more weight and a deeper snowpack, they will, any vapor movement is going to change. It'll become warmer, so you can get some rounding starting down there. Things will also start to be essentially compressed. And if we do get a deep enough snowpack that really is, deep enough across terrain, less likely to actually impact that. Also if we actually do get water into one of those weak layers that really runs through there and refreezes, that can definitely take away those persistent weak layers.
Yeah, and I guess at Hatcher Pass, we tend to not really see those thick snowpacks, and in some ways that plays to our advantage, because we might have, a reasonably sized slab sitting on a bunch of sugary snow, and we have a dangerous situation, but you then have a drought or a cold and dry period, and that vapor transfer will remove basically the moisture content of that slab and make it less cohesive, and basically break it down into a weak layer itself. And then all we have is weak layers and just great skiing. It's a little slower for those of you that are Nordic skiers and know that those sharp crystals tend to dig into the wax of your ski and not let you glide as well. But it's still nice and soft and makes for great skiing. Square pow.
Yeah.
That's what we call it.
Yeah, you're like the near surface facets run into the depth. They all just become
exactly.
You could, here you really could maybe have a layer of buried surface ore in there that's faceted out too, and a crust that facets away as well.
And I think that the crust situation that you're bringing up is just such an important part of the puzzle. Yeah. And for whatever reasons, we have just typically had colder temperatures at Hatcher Pass, so we rarely see like a rain crust form. That would be something that would cover all aspects, at a certain elevation. It'd be like this really widespread problem, but it's really rare. But over the last couple of years, it has warmed up to where we have seen rain and had problems like that.
Yeah. But those usually, disintegrate, and it gets so cold that they don't last too long. So that's good. That helps us.
Yeah, you're not naming your crusts as much as we are.
We know
I have
you
another-
guys are really crust fans. We see that.
Yes. Yep. Where are the crusts? Dave Hamry, the former railroad forecaster and definitely gurus of this area. He said his mentor told him, like, when you figure out those crusts, let me know. And so he said that a number of times, and I'm like, yes, I would like to. I'm working on it, and I haven't. Ava has a good question here as well. She said, what have you found as the most effective ways to keep message fatigue becoming an issue when talking about persistent slab problems with the public for weeks on end?
Add some Walt Whitman or philosophical, language, or it's challenging. It's challenging. I think we talk about persistent slabs so much that you just have to kind of look at it from as many different perspectives as you can. And I don't know. I would be curious, like, what people's perception is of that, and the other flip side of that.
Yeah, from
Well,
reading over and over.
We did get a interesting comment the other day through the social media that was saying repetition is good. So I think some people appreciate it. Maybe for some people it gets old. It would be really unfortunate if the message was so old and stale that nobody was paying attention to it and then they got into an accident. But I think people are paying closer attention than that.
Yep.
What do you guys do to keep
Well, and
it
I think,
spiced up?
well, and also you guys have this difference too, is that people are often, I think, tuning in because you're a couple days a week, like it's even that is sort of fresh in a way.
There's a scarcity of information.
Yeah. And so we definitely talk about it. I think it's, trying to change language and, I'll even just do stuff like, have things I think are interesting, like in the weather, or just like, I'd be like, did people actually read through the whole forecast?
Right, yeah.
I put something at the end of the weather. But just with persistent slabs, I think trying to keep those pieces in, I think what you mentioned, Jed, too, just really re-emphasizing the idea of thinking about slopes that people are riding their snow machines on or skiing on as avalanche paths. I think really continuing to think about that, because that's the big part of like how you're mitigating if it is a persistent issue and you do have something happen, whatever, weeks after the last event, if you are really thinking about what the consequences are and thinking about where the terrain traps are and stuff, that is the way to kind of manage that, that uncertainty. That's really the only way to do it. And so hopefully re-emphasizing those things.
There's this subject can be simplified, but then it can also be complex. And I think that when we have the repetitive situation going on, it offers us an opportunity to key into one aspect for that week and a different aspect. And it's just kind of an educational opportunity to spend the time to write a little bit more about those different things. So in some cases, we do a little bit of that.
Totally. And like linking to different articles and things like that, just other resources.
Yeah, making it more educational. And again, coming back to the travel advice.
Yeah. Let's see, we have another question from Rachel Johnson. I've seen many people skiing steeps at Turnagain in the last few weeks and not writing observations. Do you find that you have enough data coming in to make an appropriate judgment for the advisory on if those PWLs are truly continuing to be a risk? And how should these personal observations play into our own decision-making versus going off of the forecast alone? That's a very good question. So in our area, we use other, we use public observations as well as our own observations. So it's a combination of observations. And we definitely spend a lot of time tracking those weak layers, continuing to look, because a lot of, many of the people who are skiing or riding, which is great, many people, I would say most people don't write in observations. But we are also taking into account where people are skiing, where people aren't skiing, are places getting trafficked. And if we think that persistent weak layer is continuing to be a risk, I think one of the parts that does get hard is if you continue to have the poor structure, especially at that depth. I think figuring out, one of the other parts is figuring out how continuous the slab is. And so I think it's a really challenging question. I think when you're personally making your choice about where to go, it has to be with what the information you have and your personal risk assess, like it's more you're wanting to, what your risk tolerance is. And, I had a great conversation with one of the other forecasters today, and they talked about changing where they wanted to ski because of those facets, and that those facets are still developed at the bottom of the snowpack. Just this morning. Go
Can we
ahead.
add to that?
Yeah, of course.
Observations can vary in their quality. But one of the things I think, as just Joe Schmo who's going out and skiing in the backcountry, who isn't always just digging pits every single day and following the snowpack like the forecasters are, a tricky balance is doing your own assessments on the times that you're out there, leaning on that starting point that the forecast is giving you, but watching for observations, because the more people that enter the backcountry, they're just more opportunities for triggering avalanches. So if you're watching that from that vantage point, you're like, well, this person might have this opinion about this layer or how many taps it took to have it fail. Maybe that information is a little more ambiguous, a little bit harder to read, a little bit harder to employ in your own decision making. But if they triggered an avalanche, now that's a really key piece of information. And in any operation, the more people that are out on those slopes and the less avalanches that get triggered, that's some really bullseye information right there. I would use the observations for that.
Yeah, and I think just one quick add on there is, like Jed said, the more observations, the better. But people also, remembering that pertinent negatives are equally as valuable. So just because you don't see any wumping, cracking, collapsing avalanches, we want to hear about that too. And yeah, that's all really good information.
But a plug for having people, continue to contribute to that really valuable resource. We really appreciate it when people are publishing their observations. We're not thanking you enough. We're thanking you right now.
And we agree, and I agree. And skier, rider, like snow machine traffic is a big part of thinking about like how many people are out, are avalanches being triggered or not.
And remembering that a lot of times it's hard to know whether you've gathered all the data, you've read the forecast at your starting point, you have a lot of decision making to do from then on, but it's hard to know if you've made good decisions or you're just lucky. And I think to remind ourselves of that's really important.
Definitely. Well, I think we're reaching the end of our evening, and I just, again, really want to thank you guys for coming and chatting tonight. It's really great, and I hope, we both have great, safe seasons with lots of soft powder snow and less weak layers. It'd be really good for 2020, just like no weak layers in 2021, no weak layers. I am going to share my screen one more time and show one more little quick video to end on. Folks are welcome to add a few more questions to the chat. We'll keep that open for a little bit, and we can answer those, type some answers if you want. And on my end, we're always up for questions at staff@chugachavalanche.org if you guys have more questions after this. But thanks everyone for joining, and we'll have another forecaster chat at the end of December. I think December 29th, if I'm Yeah, December 29th is our next one. So again, thanks to Powder Hound and Alyeska for being longtime sponsors, and thank you to the Friends group for their support. And yeah, thanks so much, Jed and Allie.
Thanks
you.
for including us. It's really great to be here tonight. It was really fun.
Great. We'll see you soon.
Okay, good night.
ECTP 22 top of the facets in here. Just real weak snow underneath kind of a one finger slab. Pull that off.
This video shows the instability in our snowpack currently. We have a slab anywhere from 2 to 4 feet thick sitting on very weak faceted snow. It has resulted in many human-triggered avalanches over the past couple weeks, and also many naturally triggered avalanches, as we see here. It also was responsible for the fatality that occurred south of Cooper Landing last Monday. As we head into this weekend with clear skies and even more snow on this slab, heads up that there are dangerous large avalanches that could be triggered.
Just as a reminder of one of the avalanche cycles we saw last year, again on those persistent weak layers. I'll leave you with that. And this is one of those facets from Sunburst recently, the basal facets. Just to keep, we're hoping we can put that deep persistent slab problem to bed, but we're still gathering data on that, and you'll see that reflected in the forecast. But thank you all for joining me tonight. It's great. We'll hopefully see you out there on the slopes, either skiing or snow machining. Have a great holiday.